So all of you can see the slides clearly?
Yes, doctor.
Okay. So today is chapter 9, replacement and retention decision. Okay. Basically, it is not a new concept. You already learned some of these in the previous fundamental chapters, earlier chapters, chapter 1 to chapter 4. It's like when we are going to, actually it's when, but here we are going to see more detailed case based on, let's say you want to buy something. Previously, you decide which one to buy, right? The comparison between, let's say, machine A and machine B. Okay, so you have two machines, so you have your financial information, the cash flows, interest rate, and also the years. And then you're going to choose which one is better between two or more alternatives. Here is when, basically, is when, right? It's when to change. So those are the learning outcomes. Means that after we completed this chapter, you should be able to understand all of these listed items here. So to understand the terminology and also the basic for the replacement. Okay, and then
Doctor.
Sorry.
Doctor?
Yes.
Sorry, doctor. The display got what we call icon. I think from your computer. Is hiding the slide.
Reading this. What the words that you can't see?
Customize your view by dragging one or more videos to the stage. I mean, there's a pop-up message on your screen.
Pop message. Which part that you can't see? Sorry.
Because it's hiding the slide on the top area.
The top area.
Actually, Doctor, for me, I can see clearly.
Okay. Sorry, how about now? Actually, I don't have anything that hiding. So how about now?
I send it to your WhatsApp. The photo.
Okay. Okay. Okay.
Okay, doctor. Now it's okay. I need to think it become okay.
Oh, okay.
Yeah.
Okay, customize your. Okay, because I don't have anything that hiding mine. Okay, fine. It's okay now, right?
Doctor, now okay.
Okay. So go back to the learning outcomes just now. So explain the replacement terminology. And then I think the most important part is the number 1 and number 2. So determine the economic service life. Okay. We determine the economic service life. Basically, it's N. And perform replacement or retention study. And understand special situations in replacement and perform replacement study over specified time. Okay, because here we also are going to see if the study specified time, and some of the study are not going to specify the time, means that N is infinite, right? So we are going to see that and then calculate trade-in value for defender. So basically they are interacting or got the relationship between each of the points. Okay. So replacement means we're going to replace, right? Replace the equipment or service or anything that to improve the productivity. So reason for replacement is they listed 3 here. Reduced performance means that the machines or the equipment they have is, or reduce the performance. It's not better as first we bought it, so we need to change. Okay. Altered requirements means that now you have a different requirements. Maybe if you are in manufacturing firms, so you have certain machines to do some certain things, but later on after 10 years, the technology changed. You want to have a more automatic operation, so you need a new machines instead of the traditional machines. Okay, and also the obsolescence means that outdated. You know, you don't have. Let's say you have your old PC that you can't anymore to install new softwares. You know, so that's some of the reasons that being listed here. But I believe we have more reasons there. It depends on depends on us actually. So we have some terminology to be understood. Okay, we have defender. Defender means currently installed asset. Okay, means that the existing asset. Challenger is the new asset that we consider to replace with the defender, the currently installed asset. So potential replacement. Okay, and we have market value, the current price basically. Value of defender means that the existing machines that we have, if we sold it in a, if we want to sell, what was the value? So that the market value. And economic service life, some of the two. Actually, it's n number of years at which lowest AW. So basically, when we want to assess the replacement, we are going to use the AW. And defender first cost. This is the market value of the defender. Okay, market value of the defender. Used as its first cost P. So it's going to use as a PW. Okay. Challenger first cost, capital to recover for challenger, usually is also P, present worth. Sunk cost, prior to expenditure is not recoverable from challenger cost, means that we have some minus when we want to do the replacement. And also known owner's viewpoint. Actually, it's outsider's view or the consultant's view point on certain issues. So this is some of the terminology that we may see in the coming slides and towards the end of the lecture of this chapter. So basically the subject is engineering economy. It's mathematical, and you know, we can't just do the lecture. The best method is to do the examples, to try the calculation by ourselves. Then we are going to get to understand. So, as I explained before yesterday, previously, if we have a physical class, so basically it's going to be a very short lecture, and then we are going to do a lot of examples, and you know, and we are going to share the answer among the students, so have a better understanding. But since we are doing it online, so I'm going to cover the theory part and go through 1 2 examples, but I'm going to leave for you to try more examples to enhance the knowledge on the chapters. So example. So replacement basis. So it's given a scenario here. Okay. So an asset purchased 2 years ago for 40,000. So they bought this 2 years ago, 40,000. Is harder to maintain than expected. It can be sold now for 12,000. Or so here is the alternatives. Or it can be kept for a maximum of 2 more years. So if they cap it for 2 years, so you have more information been given. In which case, its operating cost will be 20,000 each year, with a salvage value. Means that after 2 years, when you want to sell the asset, the value is 9,000. So what this salvage value, I mean, is it present worth? Future, right? Future. And then now, So you see now the existing asset, they already give two scenarios. Okay, and a suitable challenger will have a first cost of 60,000. Means that if they want to consider a new asset, so the first cost is 60,000. Means that to buy the equipment or the machine or the asset is 60,000, and they got annual operating cost of 4,100 per year, and a salvage value of 15,000 after 5 years. Determine the values of P, A, N, and S for the defender and challenger. So in this example, we are going to use this example again and again. Okay, but here, what is the aim? We want to identify which one is P, which one is A, N, and S, right? So for defender, what is P? Because we already give the solution here, so easy for you. Okay, I should hide it and ask. That's fine. So P is 12,000. Okay, because it can be sold now for 12,000. So the value is 12,000. You see, we never bother about this 40,000. Maybe in your assignments, your projects, or you don't have final, right? But previously, if you got final exam, the tricky part is to really extract the needed information only. Sometimes you are going to tends to give more information. Like in this example, asset purchased 2 years ago. So it's nothing to do with our calculations. 2 years ago, that's why it's gone. We are not going to calculate because what the information that we take now is the current information. So P is 12,000. What is A? For 2 years, A is 20,000 here. N is 2. The sunk cost is, the salvage value is 9,000. So this is how we take the information out. And for suitable challenger here, which is the challenger. So we can see P is, because we didn't buy yet the asset. So the first cost 60,000 is P, annual operating cost 4,100, and then the salvage value is 15,000 after 5 years. So this is the first step that we should be able to, we should able to pick the right information for us. If you accidentally take N is, this 40,000, they're going to mess up your calculation later on. Okay, so this is the basic example for us to identify P, A, N, and S. So some explanation on a replacement study. So replacement studies are applications of AW method. So replacement is AW, and it makes life easier. You know, although they give a different N, they may give you case N5, N10, N20. So you have different N. If you want to calculate using P, then you need to manually shift everything to P, right? And it's not equal the N. But by doing AW, you're going to have it's more easy for us to compare. So please remember, for replacement study is AW, annual worth. So study period or planning horizon are either specified or unlimited. So the study period means that N can be specified, means that they tell you specifically what is N, or they can just say unlimited, means that the asset can be used forever. So we have if is unlimited, this is the assumptions. Services provided for indefinite future, so it's continuing forever. And challenger is best available now and for future. and will be repeated in future life cycle. What it means, if you replace with one new asset or one new equipment, so the assumption is the asset that we have replaced now is better for forever. Okay, it's better forever. And cost estimate for each life cycle for defender and challenger remain the same. Okay, means that when if they give the cost estimation for certain periods, the information, so it's going to repeat for the future. But if the study period is specified, the assumption is no more, do not hold this assumption. So we can't use this. So replacement study procedures differ for two cases. Okay, so it's different. If you want to click for specified, it's different because we are not going to use this assumption. So, okay. So now it's about economic service life. So economic service life, ESL, refers to the asset retention time. Okay, means that when the asset is retained, it's become unproductive, become no more able to fit to the condition that we want. Okay, so ESL refer to the asset retention time. So it's basically N, as I told you, it's an N that yields is lowest equivalent AW. Okay, we are going to see the example later on to give you clearer understanding on what it meant with lowest equivalent AW. Basically, we are going to calculate, to give you the concept now. Let's say you buy one asset, okay? Let's say your car, okay? And then we are going to calculate the AW every year, okay? And we are going to see what is the AW for, let's say we calculate for 20 years. So you have 20 AW. So we are going to see the AW actually is going to, either it's going down or going up. We are going to see where it's going down and suddenly it's going up. Means that it reaches limit. It's going down and suddenly it's going up. Means that we need to expand more, right? Spend more. So we are going to stop when it's almost going to increase. So you're going to see the example. So ESL is the number of years and which equivalent uniform annual worth of cost in the minimum, considering the most current cost estimates over all possible years that the asset may provide the needed service. The ESL also referred to as the economic life or minimum cost life. So we can call this ESL. We also can call it economic life or minimum cost life. Once determined, ESL should be the estimated life for the asset. So once we got the calculation, we got the answer, so that's going to be the end, the definite end. If only economics are considered based on economy, okay, based on the financial issues. If they have a political issues, they have a different other factors, then it's going to be different story. So when the end year that we calculated, years have passed, then the ESL indicates that the asset should be replaced to minimize the overall cost. So it's actually we are identifying when exactly is good for us economically to replace asset or equipment that we bought. So to perform a replacement study correctly, it is important that ESL of the challenger and the ESL of the defender to be determined, since their end values are usually not pre-established. So usually it's not been given, we don't know, right? So why we need to calculate. So the ESL is determined by calculating the total AW of cost. Total AW. If the asset as in service year 1, as I told you just now, year 2, year 3, and so on. So it's a bit tidy. You know, if they give you the study is involving 3 years, it's okay. you're going to just calculate AW for year 1, year 2, and year 3. But if it's 10, so you still need to do that manually for each year. Total AW, of course, in the sum of capital recovery, which is the AW of the initial investment and any salvage value, and the AW of the estimated annual operating cost, determined by calculating AW. So means that you're going to consider all the costs. So this is the general equation: capital recovery and be minus with the annual worth of the operating costs. So we're going to get the total AW. So let's go to the example. Okay, we give the solution here. Just avoid this, pretend like you're not looking at it, not seeing it yet. So determine the ESL of asset which has the cost shown below. They give you I. So they give you what's the N until 5. Okay, 5. So they give you at year 0. Usually year 0 is now year 0. So they bought the machine. Let's say machine or asset, whatever it is. Okay, the asset. So the cost per year. So this is very important. So we know all the information that given here is A, right? But usually the first cost would be P. That's fine. That's fine. So 20,000. Salvage value, no, because on the first, when you bought, okay, so we're not going to sell it, right? So the depreciation takes place after that. So year 1, okay, the cost is 5,000, and the salvage value means that if you sell the asset, so this is the value. Okay, so those information until year 5. So cost 6,500, 9,000, 11,000, 15,000. So this is the operating years. Okay, it may goes up, right? That's fine. So we just take until 5 cost. So when basically it's good for us to stop or to replace this asset. So basically, if we see the logic, cost is 20,000 after 5, 6, 9, 11, 15. So it's just keep increasing. 1,000 increasing 1,000, 500, and then about 2,000 plus 2,000, 4,000. So here is maybe the it just is about 2,000. So we can't really know based on our based on this information. So we need to calculate the AW. So what we are going to do, calculate the AW for year 1. So when we say year 1 here, right? So what the information that you need? Year 1, this one, and this one, right? This one. So you calculate the AW. So start with year 0 here. Actually, we're going to assume this is actually when it's year 1. When you bought it, it's going to be P, right? Although they say A, but first cost is P, as we explained just now. The first cost is when you just bought it, is P. So 20,000 P, 10% year 1, and we are going to identify the AW. And then what are the information here? And 5,000. The 5,000 here is consider. You need, if you want, you can draw the cash flow diagram. Okay, so year 0 here you got 20,000. So here is year 1. So it's also it's a 5K. And then if you sell this year 1 as well, it's going to be 10,000. So this is going to be future value. This is future. In this case, this is future. Okay, so why future 5,000 is considered as a future, and then we want to get the value for present. Okay, and then once you got this, you're going to convert it to A. I hope you understand this. This has been covered how to, shifting from present to future to annual. So it's been covered in the previous chapter. So here, by having this A, so you're going to get A for this one. And then plus 10,000, 10,000, you consider as a future, and then you identify A. So now everything is A. So let's say you done this, the calculation, so we got the value 17,000. So annual worth is 17,000. So we need to repeat the calculation for all. So now it's for AW2. So AW2 means that here, so you need all the information from year 0 to year 2. So we start with negative 20,000. Okay, we consider as a P. Okay, we want to identify A, 10%. What's the year? 2. Become 2 now. So we can't just take the information from here. We need to start new for AW. And we minus with 5,000. Now we have 5,000 for year 1, and then 6,500 for year 2. Okay, and then we find the P as this is F for this specific situation, and then we transform them to A. N is 2, and then plus 8,000. You have 8,000 here. Okay, so why we don't take into consideration this? Because you can't sell at the year 1, because they already tell you this N is 2. Okay, so we are going to just consider the salvage for specific given N. So AW2, so is only 2. If AW3, so we are going to consider only this. Okay, so now we have calculated for AW2, you're going to get 13,429. Okay, and then we need to repeat this for AW3. You know, AW3. So it's going to be longer than this, because for AW3, you need all the information from year 0 to year 3. Okay, so you need all the information here. And then for this one, as I explained just now, we are going to take the current year. So AW3 means that year 3 salvage value, this one. So you are going to calculate AW3, AW4, and AW5. So AW5 is going to be the longest. You're going to take all the information given here with and the salvage value 3. So you need to do for all. So to shortcut, so this is the value. You can try later on. So AW3 is 13,239. AW4 12,864, and AW5 is 13,623. So now we have all the information of AW for each year. Okay, so we see 17,000, and then goes down to 13,429, and then still goes down to 13,239, and it goes down to 12,864, and at the year 5, the cost increased 13,000. So we are going to cut here. We're going to choose the lowest, and means that this is the lowest, AW4, year 4, this one. So we can conclude that our economic service life is 4 years. What it means, we are going to replace after year 4. So I hope the concept is clear, although you may need to practice the calculation, but I'm explaining this is the concept. We calculate AW for each year. Year 1, year 2, year 3, year 4, year 5. Based on this example, compare each AW is going down when it starts to rebound, like to goes up from the trend. So we're going to cut them. Okay. Because the estimation is if you go to AW6, maybe the cost is going to go more higher and higher. So we cut. Okay, so economic service life is 4 years based on this example. So I hope, does it clear the concept, everyone?
Yes, Mister. Clear.
Okay, I know the calculation you may need to try to do, but I think the most important part is to understand the concept. So the calculation you can try later on. So we have questions here. Okay, I hope you can try this. So the same thing, we give the answer. Okay, you can double check with your calculation. Okay, we have 2 questions on this. Okay, so we give answer for both questions. So please try later on. Okay, so we just go through the. I will continue the lecture first. So that's the first part. Okay, so now it's about performing a replacement study. So for replacement study, we have no study period specified, and we have study period specified. So if there's no study period specified, so we need to perform the ESL analysis, like what we did just now. Okay, so we calculate the AW, and then we select the better AW. But if the study period is specified, we need to develop succession option for the product, okay, using AW of respective cash flow. And then we are going to compare. So you can use PW or AW. Okay, but I believe you see based on the information given is they give like 5 information, 4 are AW, so you just use AW. Okay, if they give you 5 information and most of them are P, just only 1 A, then you just use P, just to save your time. So no need to shift from one factor to another. So performing a replacement study for unlimited study period. So calculate the AW for defender, okay, for defender, and also for the challenger. Means that for the existing asset and also the new considered asset, right, based on their ESL, and then select lower AW. If AW challenger was selected, means that the challenger means that new equipment or new asset was selected in step 1. So we keep it for n years that we already calculate. Economic service life of challenger. Let's say you calculate the challenger n is 10. Okay, I mean the new product, if we replace it, can work for 10. It can be used or can be function well for 10 years. The old one can be function for 3 years. So we can select and use for 10 years. But if the defender is selected, keep defender 1 more year. Means that let's say when you calculate, although it's 10 years and 2 years, but the calculation shows the 2 years is good. Okay, did you get what I'm saying? Let's say you have 2 new product and the existing product, whether you want to replace or not. When you calculate, the calculation shows that it's better to keep the existing, although the life is short. Keep it. But what you need to do, keep 1 year. Means that we are not going to keep for long, but just 1 year, and then we repeat the analysis. We calculate again to check. As long as all estimates remain current in succeeding year, keep defender until their end is reached and then replace defender with the best challenge. If any estimate change before the end for defender, repeat step 1. So if study period is specified, perform step 1 through 4 only. 1 and 4. It's okay. Just go and go through the example. So basically, we are using the same case study. This is the case that we use for the previous example as well. So first, we need to determine the ESL for defender. Okay. So we have identified this thing, right? So now we need to identify the D1, D2. Defender 1, defender 2. Why we have defender 1, defender 2? Anyone? For the same case just now, if you still remember. Why we have 2 defender? I mean 2 existing asset. Hello?
So the D1 is for year 1, D2 is for year 2.
Okay. But why they calculate like this?
We want to see the ESL.
Want to see the?
We want to determine the ESL when the thing with economical service line.
Okay. So if
And
we can see
compare with
here, okay, thank you. So you know, basically, because they give 2 scenarios, it's not. We are not going to repeat the AW for every year. Actually, you see here, as we went through the example, the asset purchased 2 years ago is harder to maintain than expected. Okay, fine. It can be sold now for 12. So this is the option number 1. Okay. Or kept for a maximum of 2 years more. In which case operating cost will be 20,000 each year with a salvage value of 10,000. So D1, 12,000. We calculate the AW for D1 for year 1 here, minus 20,000. Okay, and then plus 10,000, salvage value 10,000. Okay, after 1 year, or 9,000 after 2 years. So we have, if they use it for 1 year, this is the scenario. If they use it for the 2 year, this is the scenario. So year 2, 20,000, the same thing, but it's different. There's the S. Okay. So what is the AW? They got 23,200, and here is 22,629. So how about the challenger? So they do the calculation for challenger. This one, we don't show the calculation here, but you can try. Okay, they got worth 24. Okay, it's not yet the calculation, right? So why they put it? They give it here, 20,000. It's already A, 20,000, 24,000. So based on AW, 23,200, 22,629, and 24,000. So basically here is still okay, still lower here. Okay, so they choose this option. So they can keep this for 2 years. But as we know, if the existing was selected, the existing means that the defender is selected, so we need to conduct analysis 1 year later. Okay, but as for the answer, it will be this one. Okay. Okay. And the next slide is the question for the similar replacement analysis. You can try later on. Question 3. Try to familiarize yourself with the questions and we give the answer for you to check. Okay, the same thing for question 4 and question 5. There's 5 questions. So here is additional considerations, opportunity cost approach. This is a procedure that was previously presented for obtaining P for defender. The opportunity cost is the money foregone by keeping the defender. Means that the money that we have, with the opportunity cost, the money that gone, okay, by keeping the defender, by not selling it. So this approach is always correct. So the cash flow approach subtract income received from sale of defender from first cost of challenger. So potential problems with cash flow approach provides falsely low value for capital recovery and can't be used if remaining life of defender is not the same. Okay, that's fine. So here is over replacement analysis of a specified study period. Okay, so previously is a not specified study period. So it's same procedure, except calculate AW values over study period instead of over ESL year. N for defender and N for challenger. So we are not going to calculate the N for challenger and defender, but we are going to calculate AW. So it is necessary to develop all viable defender challenger combinations and calculate AW or PW. So again, as I told before, for the replacement of a specified study period, we can use either AW or PW for each one of a study period. And then we're going to select the option with lowest cost or highest income. So we're going to see the example. So we have no option. We need to go through the examples. So hope you can understand the, the methods or the concept. So we're going to use the same example. I mean the same case. The asset that purchased 2 years ago for 40,000 is harder to maintain than expected. Can be sold now for 12 or keep for 2 more years. In which case operating cost will be 20,000, service value 10,000, or after 1 year 9,000. Or 9,000 after 2 years. And the suitable challenger will have an annual worth of 24,000 per year. And interest rate of 10% per year and over a steady period of exactly 2 years. I think this is the difference, right? Determine when the defender should be replaced. Over a study. Determine. Okay, fine. So from previous analysis, we have AW for defender for 1 and 2 and also AW. So we have this, we calculated this before. We calculated this before. And we calculated this before. So this is for defender and challenger. So what are the options that we have? Okay. What are the options that we have? So here, this is the option. Okay. So what are the options? Either what they can do. So we need to list down all the options that we have for year 1, year 2, and also the final year after year 2. Okay. So we can use the challenger, mean that we can replace, we can just sold, okay, sold it now. Means that challenger year 1, challenger year 2, challenger year 3. Right? Or you keep it for 1 year, defender. Okay, so second year is challenger, third year is challenger, means that a new asset. Or we can take another option, keep it for maximum 2 years here. Defender means that the old machine, the old asset for the year 2, and then challenger, the new machine. And we are going to calculate the AW for each year. So if this is the information given, we need to calculate what's the AW for year 1, year 2, and year 3. Okay, so we know that AW for challenger is 24 every year. So 24, 24, 24, and the average is 24. How about D? For D1, okay, is 23,200. D1. And then for D2, then they change to the new asset. So it's 24, 24. So you got the average 23. And what if they keep the defender for 2 more years? Okay, D2, using for two years. 22,629, 22,629. And then in the year 3 is new machine or new asset, which is 2024. So we got the average 23,086. So now we are going to compare here to decide. So which one is the lowest? The third one. So our decision would be option 3, keep defender, I mean the existing machines, for 2 years and then replace. So this is the concept. So I think the challenging part is you need to clearly understand the situation given and identify the option, all the options that we have for the given scenario. And then we are going to decide based on the AW, the lowest AW. So in order to get the average here, we need to calculate each year's AW based on the scenario. So if anything goes wrong in the assumption or in the options that we wrongly pick, then it's going to lead to the wrong decision. So we need to be careful. So as usual, we are going to have a example questions to be done. Okay, so basically if you want to try, you can try here, and we give you the answer as well. But it's always good for not looking at the answer first, but you try to at least to come out with the scenario, the options, how many options that they have. Okay, and then they give the information here which we can use to calculate. So we are not going to go through, I'm not going to go through the questions now, but going to provide you with the answers. I think the slides is already uploaded yesterday into the Udemy, so you can download them, download it, and then refer. So this is the answer for question 6. So you can check later on. So this is the 4 possibilities. So please try to see if you can extract those 4 possibilities. Okay, and then you calculate. Here the answer given based on PW. Okay, so try to see if you get the same answer. And this is for question 7. Okay, we give the answer here, but please try to do by yourself first. You can discuss among the colleagues, or you can try by yourself. Okay, I think this is the last part. The replacement value. Okay, replacement value RV is market trade-in value. Okay, market value or trade-in value of defender means that you have the defender that we sell that renders AW, D and also the AW C equal to each other. So we need to set an equation. AW defender is equal to AW challenger, except RV in place for P. Okay, then solve for RV. It's okay. You may get confused here. We're going to see the example later on. If defender can be solved for amount that greater than RV, the replacement value, so challenger is the better option. Okay, because it will have a lower AW value. So here we want to assess whether worth it or not for us to sell the defender. So the same example again. Okay, so it's very good that we have a same example, same case, I mean. Okay, the same case, but they give some additional information, I believe. Suitable challenger will have an initial cost of 65,000, annual cost of 15, and salvage of 18 after N is 5. So determine the RV, replacement value of the defender, that we render is AW equal to the challenger using interest rate of 10%. So what you need to do is set AW defender and AW challenger. So here is the AW for the defender. Okay, so we don't know the RV. We want to find the RV. Okay, so what is RV? Okay, RV is we consider as a P present because I want to sell now, right? P 10 2 and then minus 20,000 is the 10,000 the service value equal to AW. AW for the challenger. So the challenger's information is from here. Okay, initial cost of 65,000. So we consider this as a P and then minus 15,000. Okay, it's already in A, annual cost. And plus 18,000 salvage value means that when we sell it after 5 years. Okay, after 5. So it's a future. Okay, so future you need to transform it to shift it to the A. Okay, so if you solve this, you're going to get RV 24,228. So if the market value of defender is greater than 24,228, then we select the challenger. Okay, so if the market value we want to sell and then it's more than 24,228, then we are going to select the challenger. Means that yes, we can sell, so we select the challenger as well to replace. So I hope you can go through the example and then try the question 8 to calculate the minimum trade-in value. We know this is RV, okay? And question 9 as well, okay? What are the market value for the existing asset? So we give the answer, you can always compare. So if you got any difficulties to get the answer, the right answer like here, please let me know. Or maybe you find the answer given is wrong, okay, for any of the examples, please let me know so we can discuss, okay? So don't really believe on the answer given, maybe you find yours is better, okay? So please come back to us, but I hope all the answers given should be the right one. Okay, so we are done for the lecture part, the conceptual part of understanding the steps and also the information related to the economic service life and also the replacement value. Okay, so in short, in replacement study, P for presently owned asset A is market value. So it's market value. Economic service life is the N, the E is the lowest AW. In replacement study, if no study period is specified, we are going to calculate the AW over the respective life. Okay, so we keep calculating AW and then we compare. And opportunity cost approach is correct. It recognizes money forgone by keeping the defender, so not by reducing challenges first cost. So when study period is specified, we must consider all viable defender challenger combination in analysis. So this one that we saw just now, okay, when they specify the study period, we consider all the situation or all the options for defender and challenger. And finally is the replacement value. Actually, it's a p value for defender that renders, okay, make the AW of defender equal to the challenger. So I think that's all for the session. I hope you can go through again, you know, the slides, and also please do the example questions given in the slides. That's all. If you have any comments or you want to share something or you want to ask something before we end our session. So I will leave you. So we have time, right? And I mean, based on the class timetable, you still have time. So maybe I let you to do the revisions and things. Yes, anything?
Okay, Doctor, it's clear. No problem.